All right, this is chapters 21, 22, water pollution and solid waste. So if all things go as planned, this will be the last two chapters we have before we actually take the AP exam coming up. So starting off this chapter, taking a look at water pollution, two ways of looking at it. We can look at a pollution source that's going into the water supply as being either a point source, which pretty much means you can point at it. It's coming from here. Or it could be a non-point source where you're looking at the river or area and saying, yes, we definitely see there is pollution going in, but where is it coming from? It could be coming from some agricultural feed, parking lots, storm drains, a variety of different things, but we're not looking at a particular source itself. Okay. A couple little shots here. Obviously, this looks like a pretty clear indication it's coming from this location. But another example with these cows, this may be one of many type locations where the pollution could be coming from. All right, little vocab here. BOD, sometimes it's listed with BOD 5 over a 5-day period. But BOD is the amounts of oxygen that's required to break down some biological matter. Usually we're talking about algae. Algae a lot of times is present in water, and usually it's a sign of excess nutrients that are being provided to the waterway. So the more nutrients that are being provided, the more algae you're going to have, which decays over a period of time, which is going to increase the amount of bacteria which is in the water, which is going to consume oxygen. So the higher the BOD value, the more, or I should say the less amount of oxygen you're going to have available in the water. So what you want is a really low BOD value, which is going to make more oxygen available for aquatic life. All right, quick short little list here of a couple little pathogens, things we don't necessarily like to have in our water supplies, but could end up there. And again, these are things we don't want there. So you can pause this and take a look at this if you'd like. Some other little contaminants here. Most of them are metals, but then we have some organics along the way as well. Lead pipes, you know about that. Arsenic, we will talk about more detail a little later on, but it is a natural contaminant. It's not something that necessarily comes from factories. It's in the ground. It's in the bedrock. And a lot of times it enters the water supply a well just through the drilling process, so it disturbs the bedrock, and it's not at all uncommon to have it to some degree, but it's a much bigger problem in other parts of the world, which we'll mention later. Mercury we mentioned a long time ago, well, I guess last chapter, but mercury is more of an issue when you have coal-fired power plants somewhere along the line. That's going to contribute to mercury becoming airborne and finding its way into the water supply. Acids, a lot of times we mention this with acid mine drainage. So you have an old abandoned well site, mine someplace, becomes flooded over a period of time. That's what happens. These things are really deep. Water gets in there. Water mixes with pyrite, which is an iron compound. So that releases iron, not necessarily a big deal, but also in the process acidifies the water supply, which in itself isn't necessarily a huge problem. Over a period of time, yes, I guess it is. But what it will also do is it can leach other metals out of sediments that may otherwise be tied up. So that's a potential problem. Synthetic compounds, also many times called SOCs, synthetic organic compounds. Typically you're talking about things like pesticides and pharmaceuticals. These things may be persistent, which means they hang around for a long period of time, and they can have some serious biological problems as well. In sediments, that has a variety of problems as far as just blocking out the sun or just making life a little bit more miserable for those that have to live in those conditions. Alrighty. Dirty dozen. We mentioned this as something called POPs, persistent organic pollutants. And again, persistent means that these chemicals will hang out in the environment for a long period of time. And we see that these have been banned, and they're no longer in use. But it'd just be a good idea to kind of just be familiar with what these things are. Just take a look at their names. If it's hard to pronounce, it's probably, well, maybe a chance it's on the Dirty Dozen list. Okay. Pesticides. What's the big deal? Well, if something, the way I always learned it a long time ago, if something is bad for one part of the environment, it's probably not necessarily good long term for anything. So we like pesticides. We use them quite a bit, whether it's for weeds or insects or fungicides, whatever you like. But if it has a negative downside to one species, the upside isn't typically good, especially when you're getting into how it interacts with the organism's chemistry. The only thing you're kind of hoping for is that these pesticides are not persistent, that they do break down quickly. But again, we don't know what kind of effect it's going to have on the non-target organism along the way. So it could have a variety of potential problems that you see here. Another problem is listed here with these inert ingredients. So these are things that a lot of times the manufacturer doesn't necessarily have to worry about because they're not active ingredients. But sometimes those can have just as much or worse of an effect on an organism or something else in the environment as the actual active ingredient did. So it's something else that needs to be looked at. All right, just a little while ago we were discussing BOD, and this is the other side of the equation, the DO. So this is the oxygen demand. So when we're looking for a number here, this is just a nice indicator of a healthy water supply. There's a lot of oxygen that's available for aquatic life. And notice that also we're at 20 degrees Celsius. Theoretically, if this number was to drop, colder water, that's a good thing because colder water can hold more oxygen. So this is the dissolved oxygen that is available for aquatic life. And again, the higher the number, the better. We want our dissolved oxygen content to be high. And just as a note, it's marked in parts per million. So one more time. Dissolved oxygen high, biological oxygen demands we want low. Okay. Moving along, as far as another pollution source, people have evolved growing up living around rivers. It was a necessity having a water supply. The problem is that it's also a really good resource as far as disposing of waste and washing of waste. So potential problem is if you have people that are, for example, putting waste into the water in this location and water is flowing downriver, these people may be obtaining their drinking water that is contaminated from the practices going on downstream. And that's not at all uncommon. Small example where I think we're okay, but we get our drinking water from the Great Lakes, but we have to deal with all of the output of places like Saginaw, going all the way around to say Traverse City or Duluth. We have to deal with all of their waste, and of course we deliver all of our waste down to Cleveland. So you're welcome, Cleveland. This is for you. And this kind of shows that idea in a very vivid example. Here is a sewer or something that's putting waste out into the water. So originally you have some nice good indicator organisms, mayflies, stoneflies, some macroinvertebrates, and then you have trouts, which you're typically not going to find in the Rouge River, not anywhere around here. And this is clean water, so that's not one classification. You'll see this in your notes. Notice that the biological oxygen demand is quite low and the dissolved oxygen is quite high. All those things are good. But then once the pollution source goes in, this is organic matter, the dissolved oxygen is going to be used up by the organics to break them down. The BOD is going up by definition. And then you don't have a whole lot of species that are going to be able to hang out in this polluted water. So you're going to see that you're pretty much going to have some low quality organisms hanging out in here, no offense. And then over a period of time, the solution to pollution is dilution, and the organics are going to be broken down, and then once they kind of dissipate, you're going to have those go away, and the water will clean itself just by dilution, and the dissolved oxygen again will return back to normal. So that seems to work for some places, but not everyone can do this. And over a period of time, again, it makes that part of the environment, this particular location all the way to the recovery, a polluted location. Okay, good place to stop for the end of lecture 1.